Thank you, Jairos, for inviting me here to present and also learn about some of the bioanalytical issues when we face with bispecific moieties. So there has been very great interest in the recent times for bispecific biologics. I thought this title was pretty catchy. Bispecific antibodies. It just review came last year. Pretty interesting review about the broad issues and then the highlights about the recent interest in this area. There have been several companies that have got into collaborations with other smaller companies to discover and develop some bispecific entities, novel constructs. Of course, they are novel constructs. On top of it, they are bispecific. My own company, Boehringer Ingelheim, well, it's a public information that we have made a collaboration with Macrogenics and F-Star. So that's our interest in bispecifics, as many other leading companies. And there have been a varied set of receptors and targets that have been aimed at by using the bispecifics. I think it all started with the oncology area. However, in the recent times, we have gone beyond oncology and going more towards immunological targets, maybe even some metabolic type targets. There have been multiple literature reports that are available that suggest that the target class do not have to be the cancer area. I will start with some brief introduction of bispecifics, as though you really need it. I don't think you need it, but I will just give just the introduction that would act like a segue to what I'm going to talk about. And mainly the target types. This is just a broad target type of and the impact of the target types on the bioanalysis, and then the general bioanalytic conditions for monospecifics and how does it remain the same or adapt to the bispecific area. And again, some general strategy and the scope, and then the timing of the assays, and then some reagents, and how do we really handle, or how should we handle ADA or immunogenicity for bispecifics, and how could that be different from a monospecific molecule. We can look at bispecifics with respect to both functions and then the types, structural types. When it comes to functional classification of these molecules, we could be targeting two ligands. We could be targeting two cell surface receptors. We could be targeting a combination of cell surface receptors and then the soluble ligands. And again, based on the catomaximab or rimovab example, when we talk about bispecific, they're bispecific intentionally to a particular set of targets. However, they can also have additional functions like maybe binding to Fc gamma receptor. And so fulfilling the criteria for probably a third specificity. Do we call it a trispecific, or according to the company, they call it bispecific but trifunctional. I still do not get the difference between a trispecific molecule versus bispecific trifunctional. Structurally speaking, there are 7 main types of bispecific molecules. There are